All right, so here we go. Rectangles, rhombi, which is the plural of rhombus, and squares. So we got a bunch of theorems. Let's do the first one. It says the diagonals of a rectangle are congruent. All right, so we haven't really talked about that before. But if you have a rectangle, the diagonals, remember what the diagonals are, right? So if I go from one corner to another, to a non-consecutive vertex, do you see that? That's a diagonal. There's another diagonal you could draw from this one to this one. So those are all your diagonals. And let's call this A, B, C, D. All right. So, and this is a rectangle. So what kind of angle do we have right here? It's a right angle. So all four of these are right angles. Agreed? Okay. All right, so they're all four right angles. So this is specifically a rectangle. This is not every parallelogram, okay? This isn't just a rhombus. This isn't a square is a rectangle, so it could be a square, okay? Everybody hear that? So it could be also true about a square. It's not a trapezoid. It's not any of those things. It's not just a basic quadrilateral. This specifically is a rectangle. Everybody got it? And what do they say? What does that first theorem say? It says the diagonals are what? Congruent. Okay, so what could I write down? What little statement with these letters right here could I write down if I said that these diagonals are congruent to each other? It's not angle. Diagonals aren't angles. Diagonal is a length. It's a length, so it's not an angle. Okay, the diagonals are the actual line segments right here. So you're not going to say angle. Alex?
Would it be something along the lines of, would it be something along the lines of,
I get it, lines.
AC is congruent to BD, something like that?
Well, it wouldn't be something like that. It would be exactly that. All right, so AC is equal to BD. Those are your diagonals, all right? Now, I think I remember hearing recently somebody saying, what does that mean, AC? Or I think it was on the quiz, maybe somebody asked me about, all right, sorry, just had a text, had to read it. Now I lost track. I heard, like on the quiz, it said like AC is equal to what? Had a blank right there. And I saw on several of your quizzes, people are putting stuff like angles down. You're putting something degrees. Okay, this doesn't mean a degree. This isn't an angle. What is it? It means what? AC. If I just said AC equals, what does that mean? It's not a line. It's a line segment, but it's not just a line segment. It's the what? It's specifically the what? The length of the line segment, okay? That's what this means, all right? We've talked about that a lot in the past, and I guess we forgot about it. You cannot write down equals something degrees. If I ask for AC, right, you can't say it's 27 degrees. That doesn't make any sense because this is a line segment. Line segments are not measured in degrees. Everybody got it? You would just write down a number, all right? So AC is equal to BD. That's what the theorem says. Again, it's only true about rectangles. Is it true about like any parallelogram? No. All right. Now, a rectangle is a parallelogram, agreed? But it's a specific type of parallelogram. So the diagonals are not equal to each other or congruent to each other on any parallelogram. Now, they do something, though. What do diagonals do on a parallelogram? They bisect each other, okay? So what do you think might be true here as well? Like if I put an M right there. So BM would equal to what? MD. Everybody see that? All right. But watch this. What would be true about BM, MD, MC, and MA? They're all equal to each other. That's right. Because we know a rectangle is a parallelogram, so they bisect each other. And we also know it's a rectangle, so the diagonals are equal to each other. So this one and this one are both split in half, but they're both the same, right? So if I take the same two things and split them in half, then this, 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 and this are all equal to each other. Agreed? Okay, enough of that. So that's our first theorem. I'll tell you what, there's a specific example that they give for this. It's in the book, but since I got this picture here, I'm just gonna use this. So what if they said that, let me make sure I'm doing this right, because I'm using different letters here. What if they said AC was equal to 5x plus 2, and BD was equal to 7x minus 6? And they ask you to solve for AM. So they say, I'll put it over here, AM equals blank. Everybody got it? Okay. So why are they equal to each other? Because the diagonals of a rectangle are equal or congruent, right? So AC is a diagonal, BD is a diagonal. They kind of give you what they're equal to, right? So what do? You set them equal to each other because the diagonals are congruent. I would do it like this. I'd put the 7 first. Doesn't make any difference. But you set them equal to each other. Now, of course, what are we going to do here? We're going to solve for x, okay? But is that going to necessarily be our answer? No, because what we're trying to do is we're trying to find the length of AM. We're trying to find that length. To tell you the truth, if you find any of those four, they're all going to be the same, correct? Okay. So let's do it. Subtract a 5x from both sides. What do you get? 2x. Add a 6 to both sides. What do you get? 8. Divide by 2, you get 4. Okay. So x is 4, but that's not my answer. I got to plug it in, right? What am I going to plug it into? Well, I don't know what AM is, right? But I do know either one of these. So let's find like AC, all right? If I find AC, then what do I do to it to get AM? Just take it in half, right? Just split it in half. Everybody see that? All right, so let's find what AC is, that whole entire thing. So AC is equal to 5x plus 2. So 5 times x, which we found to be 4, plus 2, that's what? 22. But is that my answer? No, because they asked for AM. That's AC. So how do I find AM if I know AC? Split it in half. So what is AM? 11. All right, there it is, right there. That's the kind of stuff they're going to give you to do. That's the kind of stuff you're going to see on the homework. That's the kind of stuff I'm going to put on the quiz. Got it? All right. If you took good notes on it, and if you go back and review it, because I don't know when the next quiz is, it's probably going to be relatively soon, probably early next week, because we already did 6-3, right? And this is 6-4, and I try to give you maybe every 2 lessons have a quiz, maybe 2 or 3 lessons. So I haven't figured it out just yet, but probably early next week. We'll probably have a quiz on that. My guess would be Tuesday. I don't like usually, I could give a quiz on Monday. Maybe we'll give it on Tuesday. Maybe Wednesday. I don't know. You'll find out on Monday when I hand you out the thing. All right. Let's do another one. Here's another theorem. It says, again, I'm not going to write it down, but if you want to write it down, feel free. It's in the book. Just takes too much time. It says each diagonal of a rhombus. So let's draw a rhombus. Turn this back into white. So what's a rhombus? A rhombus is like this, but I'm going to transform. I'm going to change that to about like that. All right. And I think by, let me stretch it out a little bit. That looks pretty close. When I say pretty close, what am I trying to do? I'm trying to get all 4 of these sides what? Equal to each other, okay? Everybody got that? So that's what a rhombus is. It's just it's a quadrilateral with 4 equal sides, all right? And a lot of times they slant. They don't always have to slant. They could be straight up and down. Then it would be a what? A square. Is a square a rhombus? Yeah, because all 4 sides are equal. But a square is also a rectangle, isn't it? And it's a parallelogram. Square is a bunch of stuff. It's not a trapezoid, but it's not a kite. But it's almost all the other one. I think it's all the other ones that we talked about. Okay, so what does the theorem say? It says each diagonal of a rhombus bisects 2 opposite angles. So what do we need in here then? It says each what of a rhombus? Are you looking at the book? Each diagonal. So we're going to draw a diagonal here. And we're going to draw a diagonal here. Does it mean the diagonals are equal to each other? No, they're only equal to each other if they're diagonals of a what? Of a rectangle. Okay, so the diagonals are not equal to each other, but they do what though? So far that we know. They bisect each other, right? So this one right here and this one are equal. This one right here and this one right here are equal. But that's not what the theorem says. This is a new theorem. This is something different that we didn't know before. Okay, and what does it say? Each diagonal of a rhombus bisects what? Not just each other, but two opposite angles. All right? So let's put some letters in here. I don't know why I did this, but I started up there. And let's put some angles in here. Let's go 1, 2, 3, 4, 5, 6, 7, 8. All right. Now, I'm not going through the proofs of these, and I'm not even going to explain, like why all this is true, because we got so many of these to get through. It would just take way too long, okay? So there are theorems. They can be proven, all right? But we're just going to accept it. Is that all right with you? All right, so let's do this. So if this theorem is true, if the diagonals bisect opposite angles, what must be true here? What's true about 1 and 2? They're equal to each other, all right? Because it bisected this angle. See this diagonal? It split that big angle D in half. So that means 1 and 2 are equal to each other. What else is equal to each other? I tell you what, let me say this. What else is equal to angle 1 and 2? That'd be a better question. Why is that? Yes, I don't think the book says on the same thingy. What's true about the opposite angles of a parallelogram? They're congruent to each other, right? Okay, so this big angle D and this big angle B are equal to each other. So if I split this angle, let's just make up a number. Let's say it was 60 degrees, okay? What if that big angle was 60 degrees? All right, then what's angle 1 and 2? Come on, play along, please. If the whole big angle is 60 degrees, you're not thinking, okay? We're not thinking. It's a super easy question. If the whole big thing is 60 degrees, then each of these are 30 because it bisects the angle. Now, if angle D is 60 degrees, what's true about angle B? That whole angle B is 60 degrees. And if I split that in half, what are each of these? So what's true about 1 and 2 and 5 and 6? They're all equal to each other, correct? If it was 60, then all of these would be 30s. Everybody see that? So, likewise, what's true about 3 and 4? So 3 and 4 would be equal to each other, and they'd also be equal to 7 and 8. Okay? Does that mean that all these up here are equal to all these down here? No. Because if this was 60, if that was 60, what would this angle be right here? It'd be 120. So then 3 and 4 would be 60, 7 and 8 would be 60. You with me?
Yes, sir.
Okay. So that's what that theorem says. I didn't write it down, but you probably should write it down. That the angles of a what? Rhombus, I should do this, just to make sure we know that that's a rhombus, right? So if all four sides are equal and you draw your diagonals, they bisect the angles, the opposite angles. Okay. That's good. Here's something else that's true. I'll tell you what, I'm going to use the same picture so I don't have to redraw it. Because it starts off the same way. It says the diagonals of a rhombus, they do something else too. Okay? They bisect each other, they bisect opposite angles, but check this out. Look at the angle that's formed in the middle here. What does it kind of look like?
Triangle.
This angle right here. It looks like a right angle, doesn't it? It is. Okay? Now, we could go through a proof on it. The proof would include like congruent triangles and all that kind of stuff. But you would find out that this is a right angle. So it is true. It's a theorem. We should prove it. We're just not going to because of time. But that would be a right angle. So our theorem says this. If you look at it, I don't know what page it's on, but it says the diagonals of a rhombus are what if it's perpendicular? What's true about the diagonals? If I gave it away, I said it really quickly. If that's a right angle right there, what's true about the diagonals? They are, give me a good geometry word. Say it, Lua. Perpendicular. I saw her mouthing it. So they're perpendicular. Okay, so the diagonals of a rhombus, they do a lot of stuff, don't they? They bisect each other. They split the opposite angles in half. And they are perpendicular to each other. So I have right triangles in here, don't I? In fact, all four of these are right triangles, right? This one, this one, this one, and this one. because they all have right angles. Because if that's a right angle, then all the other ones are right angles as well. Agreed?
Nice.
Okay. All right. We're rolling right along. I'll tell you what. They give an example, example 2. I think I've explained this enough where you should be able to do that. But what I would do, listen, this is going to take a little extra effort on your part, but if you're willing to put out the extra effort to learn this, if I were you, I would go through example 2 on your own, put it in your notes. If you have a study hall today, or if you got a time where you can do this, or at night tonight, do example 2 before you even start doing the homework. All right, because they give you a good explanation, they show you how to do it and all that kind of stuff. But I've got a lot more theorems to go through, so let's go through them, and I only have like 6 minutes left. All right, so here's another one. Don't really have pictures for these, because this kind of, do you remember the other day on 6.3, we said we had a parallelogram, and we said we don't know that this is a parallelogram, but if the diagonals bisect each other, what does it make that thing? It makes it a parallelogram. Agreed? If the opposite angles were equal to each other, what does it make that four-sided figure? It makes it a parallelogram. Remember that? So that's what we're going to do right now. So let's take a look at the next theorem. It says if, I'm just going to shorthand it right here. I'm sorry. I got ahead of myself. If the diagonals, I'll write it down. If the diagonals of a parallelogram are equal to each other, then what is it? So if you have a parallelogram and the diagonals are exactly the same, what kind of figure do you have?
Square.
Well, it could be a square, but more generally, no. It says if the diagonals of any parallelogram are equal to each other. It's kind of like the opposite of what we just did on that first example today. But we don't know that it's this. It's a rectangle, that's right. So if the diagonals of a parallelogram are equal to each other, so if you have a parallelogram, right, and the diagonals are equal, what does that make it? It makes it a what? Then it's a rectangle. It's kind of the opposite. We call it the converse, okay? If it was a rectangle, what do we know about the diagonals? The diagonals would be equal, okay? So if you have a parallelogram and the diagonals are equal, what does that make it? It makes it a rectangle. Somebody get that, please? Okay, it is. It's like the opposite, okay? So watch. Let's do another one. If the diagonals are parallel, watch. If the diagonals, I don't have a special symbol for diagonals. Thank you. If the diagonals of a parallelogram, so we'll just write the same exact thing, could have just copied and pasted that, are perpendicular, I'll just put the symbol for perpendicular, then what is it? What kind of specific parallelogram is it? If the diagonals of a parallelogram are perpendicular, then what kind of figure is it? It is. It's a rhombus, right? We just finished doing that, didn't we? We said if you had a rhombus, then what's true about the diagonals? They're perpendicular. But this one says if you just have a parallelogram and you find out that the diagonals are perpendicular to each other, then what must it be? It must be a rhombus. Okay? All right, we have another one. I'll just copy and paste that. Okay. We can get rid of the R right there. Okay, so if you have the diagonals of a perpendicular, or if the diagonals of a perpendicular bisect each other, bisect a pair of opposite angles. A pair of opposite angles, then what kind of thing is it? What did we have when we bisected the pairs of opposite angles? What was that? It was in your notes. Just look at your notes. It should be just right above what you're writing right now. if you bisect, okay, if you had a thing and you bisected the opposite angles, what kind of thing is it? What kind of object? What kind of quadrilateral is it?
A rhombus.
That's it. It's a rhombus again, okay? So anytime you take a rhombus and you bisect, or you put the diagonals there, what are they going to do? They're going to bisect the opposite angles, aren't they? Then it's a rhombus. So there's a lot of things that are true about a rhombus right there. Right, because a rectangle is not a rhombus. A rectangle, only if that rectangle was a square. Okay, only if it was a square. Okay? I got two more to do, and time's running out on me right here. I'll just read it off to you, okay? The next theorem says if two consecutive sides of a parallelogram are congruent, then it's a what? So let me just try to draw. Boom. It's going to take too long. Bell's going to ring any second. So I'll just read it. Okay, if two consecutive sides of a parallelogram are congruent, then it's a rhombus. And then here's the last one that I want to show you real quick.
If you have health tech next period, it's going to be in the NCR. And Chick-fil-A breakfast sandwiches will be sold tomorrow for $4.25.
What do you think is true about both of these lines right here?
And we'll announce the price later.
Yeah, they're parallel to each other, okay? Just hang on. So this is parallel to that, okay? They're parallel to each other. Now watch this. The distance. Remember we talked about the distance from a point to a line? So if I put a point right here, what is the distance from that point to this line right here? Is it from there to there? Is it from there to there? It's what? Give me a good geometry word. It's not vertical. You're on the right track. It's perpendicular. Very good. Okay, watch. It's perpendicular. Everybody see that? Okay, now watch this. So that's the distance. That's the distance from that point to this line. What if I put another point on that first parallel line? Where would the distance be from there? It would be perpendicular as well. Agreed? Now, here's the key to this. What do you think is true about these two distances? Look, everybody look up here. Okay, what's true about these two distances? They're the same. They're exactly the same. Okay, and that's what the theorem says. All right, you have your homework. I gave you the I always forget the name of that lesson plan thing on Monday. So I'll just write it down if anybody's watching this on YouTube. So it's page 272, 273. So this is your homework. And it's 1 to 11. There it is, right there. Put it right there.